In this video, I will clear up a very big misconception regarding acceleration and deceleration. The misconception is this: a negative acceleration is a deceleration. While there is some truth to this statement, however, it is very misleading. Let us take an example. Consider a body moving initially at 10.0 meter per second to the right, and it decelerates uniformly to reach 4.0 meter per second to the right. The time taken for this change in velocity is 3.0 seconds. Find the deceleration of the body. Now let me show you how this question is tackled in many textbooks and in many physics teaching lessons. The equation for uniform acceleration is written as follows: A equals to V minus U divided by delta t. Then what happens is that a lot of people then interpret U as the magnitude of the initial velocity, V is the magnitude of the final velocity, and A is the magnitude of the acceleration. Then they substitute and obtain A equals to 4.0 minus 10.0 divided by 3.0, which gives minus 2.0 meter per second squared. And then this negative acceleration is interpreted as a deceleration. But let me ask you one question. How come the magnitude of the acceleration is negative? The magnitude of a vector is defined to be just a number. So interpreting A, V, and U as magnitudes of the vector quantities is wrong. Also, the quantities A, V, and U are not the acceleration vector, the final velocity vector, and the initial velocity vector respectively. So what are A, V, and U? To address this issue, let me show you how the equation is written originally. It is written like this: A equals to V minus U divided by delta t. And if you contrast this way of writing the equation for uniform acceleration with the way the equation is written previously, you can immediately notice that the vector quantity is here, A, V, and U. Now all contains an arrow on top of them, indicating that they are vector quantities. Now, if you want to remove the vector arrow on top of each vector quantities, we need to do so in accordance with an axis in place. For our problem, let us place an x-axis as shown. Then we place x hat to indicate the direction of our x-axis. Now we can write our equation as follows: A subscript x equals to V subscript x minus U subscript x divided by delta t, where Ax is the component of the acceleration vector in the direction of the x-axis. Vx is the component of the final velocity vector in the direction of the x-axis. Ux is the component of the initial velocity vector in the direction of the x-axis. Whenever you see the equation for acceleration written as A equals to V minus U divided by delta t without any arrow on top of the vector quantities, remember that this equation has to always be interpreted with respect to an axis. So A, V, and U here means the components of the vectors in the direction of the axis. In our problem, we have ux equals to 10.0 meter per second, vx equals to 4.0 meter per second, delta t equals to 3.0 second. If we substitute, then we have ax equals to 4.0 minus 10.0 divided by 3.0, which gives us minus 2.0 meter per second squared. The component of the acceleration vector is negative. This is telling us that the acceleration vector is contributing minus 2.0 meter per second square in the direction of the x-axis. In other words, the acceleration vector is contributing plus 2.0 meter per second square in the opposite direction of the x-axis. Now let us choose our x-axis to point to the left instead of to the right. We have our x-hat pointing left this time. Then we write ax equals to vx minus ux divided by delta t. So here we are going to have ux equals to minus 10.0 meter per second, vx equals to minus 4.0 meter per second, delta t equals to 3.0 second. Hence we have ax equals to plus 2.0 meter per second squared. And as you can see here, ax is positive, but does that mean it is not a deceleration? Just because it is positive? No, it is still a deceleration. The reason it is positive here is because we have taken the direction of our x-axis to be to the left. Therefore, a negative acceleration does not necessarily mean a deceleration. A negative acceleration is a deceleration when two conditions are met. These two conditions are, number one, our x-axis direction points in the direction of the initial velocity. Second, the initial speed is greater than the final speed. When doing physics at lower grades, what happens is that most of the time we encounter problems where the motion is taking place along a straight line without any change in direction. These two conditions will always be met for a body moving in a straight line. This is why they write the equation A equals to V minus U divided by delta t without even mentioning these conditions. And then interpret a negative acceleration to be just a deceleration. So this is it for the video. I hope you liked it. If you liked it, then press the like button, subscribe on the channel, and share the video. Thank you very much. Until next time.